This video is going to cover proportional relationships. Alright, so proportional relationships are relationships in which two quantities vary directly with one another. Basically, if I told you you doubled one thing, the other would also have to double. So they have to be changing at the same rate, they have the same unit rate, and they have equivalent ratios. So for an example, let's say I tell you it costs $3 per baseball. Alright, so 0 baseballs would cost 0, etc. 1 would be 3. This is a proportional relationship because it's changing by that same rate every time, $3 per baseball. There also are equivalent ratios. So like, let's say I say 1 baseball costs 3 and 2 baseballs cost $6. These are equivalent because to get from 1 to 2, it's doubling, and then the price also doubled. 3 times 2 is 6. So this is a proportional relationship. All right, so I have a situation and I want to tell, is it proportional or not? So it says Randall, he paid $6 for 2 baseballs. So I'm going to go ahead and fill in a table with kind of information that I know. So first thing, if I bought 0 baseballs, I know it cost me $0. Same kind of thing. I'm not quite sure how much it is for 1 baseball yet. For 2 baseballs, I know it's $6. Okay, I could maybe figure out 3, 4. I could figure out a bunch of other ones. Okay, so let's kind of think about this as a unit rate. I know I paid $6 for 2 baseballs. I don't want to know for 2 baseballs. I want to know, well, how much is it for just 1 baseball? Well, to get from 2 to 1, it's divided by 2. So 6 divided by 2, that gives me 3. So I just found the unit rate. It costs $3 for 1 baseball, so I can fill that in now. So now, if I wanted to figure out how much 3 baseballs would cost, well, it's $3 per baseball, so 3 times 3 is 9. If I wanted to figure out 4 baseballs, 4 times 3 is 12. 5 baseballs, 6 baseballs, okay? So I can figure out the cost there. Now, if I wanted to know how much would any amount of baseballs cost, I could try to write an equation. I could say, well, my cost, it's $3 times however many baseballs I buy. Let's say I call that X. Here would be my equation. Okay, now I wouldn't have to use C. I could call it Y equals 3X, whatever you want to call it. Just we should always try to make sure we say what everything stands for. So I'm going to say the X is the number of baseballs. And then I'll say the Y stands for the cost. That's what it stands for. So to find my cost, I do $3 times how many baseballs I buy. All right, this is a proportional situation because it's changing by the same amount every time. The unit rate is 3. Okay, every single baseball costs $3. Now, I just want to point something out. In our equation that we wrote right here, this number that I'm timesing by, that's always my unit rate. That's important. I also want to point one other thing out. When you're looking at a table, if you're trying to see if something's proportional, you can basically divide, let's just call this the X, this the Y. You can basically divide this one by this one. So I could do 3 divided by 1. That gives me 3, right? Here I could do 6 divided by 2. That gives me 3. I could do 9 divided by 3. That gives me 3. 12 divided by 4. That gives me 3. Every time I divide, I get that same thing, 3, which is my unit rate. That's another way to tell if it's proportional or not. All right, now I'm going to make a graph of the situation. Okay, so I'm going to put, this is my X and my Y axis. Okay, I'm going to put 0 right in the middle. I'm working with how many baseballs I buy, so I'm going to go ahead and write down here. Here's my number of baseballs. And on the Y axis, I'm going to put, here's the cost. Okay, so for number of baseballs, I want to know how much does 1 baseball cost, 2, 3, etc. Okay, I'm putting those right on the line. And then the cost, I know, starts out at 0, but it's going by 3s. 3, 6, 9, 12, 15, 18. Okay, so I'm going to start plotting some points. I know 0 baseballs cost me $0. 1 baseball cost me 3. 2 baseballs cost 6. 3 baseballs cost 9, 4 cost 12, 5 cost 15. I could keep going, right? 6 cost 18. I could keep going. I kind of see a pattern here. So I'm going to connect this. Okay, there's a pattern, and it keeps going. Okay, I just made a graph for this situation. Now, I want you to notice a couple things about this graph. First thing, do you guys see that it makes a line? That's called linear. Okay, in order for something to be proportional, it has to make a line. It has to be linear. Something else that's important is it goes through this point 0, 0. All right, that's very important. When it goes through 0, 0, it's proportional. If it doesn't go through there, it's not proportional. It also has to have a common unit rate. The unit rate in this case is it costs $3 per baseball. That's the unit rate. So this is a proportional situation, again, because it's linear. It goes through 0, 0, and it has a unit rate. All right, now let's take a look at another situation, and we're going to try to see if we think this is proportional. So it says Jordy, he paid $3 to get into the fair, and then $2 per ride. All right, so let's think about this. If Jordy went to the fair and he went on 0 rides, but he still went into the fair, he still has to pay $3 to get in. Okay, so he paid the $3 no matter what. So then he went on a ride. So if he went on one ride, he pays that $3 plus he pays the $2 for the ride. So he'd be paying $5 for just one ride. Okay, if he went on 2 rides, he's paying that $3 to get into the fair plus $2 for one ride, $2 for another ride, that'd be $7. Okay, if he went on 3 rides, he'd be paying the $3 plus 3 times, and that'd be giving me $9. And then this would be $11. All right, so that's our table for this problem. All right, now let's see if we could write in our equation. Let's call the number of rides he goes on X, and let's call the cost Y. Okay, so to find his cost, I know he's paying $2 per ride. So that is 2 times however many rides he goes on, plus he always has to pay that $3. Here's what the equation looks like. All right, now we want to know if this is proportional. Now there's a couple different ways you can tell that. Well, first thing, is there a unit rate? Well, there is. It's $2 per ride. But is that when you divide these out, is that what you get? Well, let's kind of think here. If I divide 5 divided by 1, that's 5, right? Here, if I did 7 divided by 2, right? 7 divided by 2, that's 3.5. If I did 9 divided by 3, that's 3. Are any of these the same when I divide those out? No, they're not. So these are not proportional. Okay, this situation, again, is not proportional. And the reason that is because it does have that $2 per ride, but you paid that $3 fee to get in to start with. So that kind of changes the cost depending, just because of that. So this is not a proportional situation. Now, I do want you to notice the equation looks a little bit different than our other one. Okay, what's special about this one is this has that extra part added on. That kind of makes it not proportional. Okay, if it just said like 2x, that'd be fine because it's changing by $2 every time. But because you add on that extra fee, it's not proportional. All right, now that we've seen this and we know it's not proportional, let's see what the graph looks like of one that's not proportional. All right, so if I went on 0 rides, it still cost me $3 to get into the fair. If I went on 1 ride, it cost me $5 for my whole time at the fair. If I went on 2 rides, it cost me $7. Okay, if I went on 3 rides, it cost me $9. Now you can kind of see a pattern. It's making a line, so I'm going to go ahead and connect this and put an arrow on the end. All right, now, first thing that you guys might notice, well, it is linear. It does make a line. So usually that makes it proportional. But does it go through 0, 0? Okay, it does not. It starts up here. Okay, it starts right here. So this is not proportional just because of that 3. It started at the 3. Then it was going up by $2 a ride, but just because of that 3, that makes it not proportional. So that's what a graph looks like of a not proportional situation. Okay, let's add this to our notes. It says, what do graphs of proportional situations look like? Well, we just found out that they're linear. They have to make a line. It has to go through the point 0, 0 on your graph. And it has to have a constant unit rate. So it needs to be like changing by the same amount every time. All right, so what do equations of proportional situations look like? Well, the equations that we worked with all start with whatever. This could be a C or a Y over here. And then it's going to equal your timesing by something. And you can't be adding anything on. So in this one over here, do you see how you're adding that to 1? That makes it not proportional. So that one isn't. This one, it just says y equals 3 times x. That one is. If I give you one like this, y equals 5x. Or y equals 1/2 x. Something like that. Those would all be proportional situations. There's also something called the constant of proportionality in math. All right, the constant of proportionality is a constant ratio or a unit rate in a proportional relationship. So basically, I'll just kind of show you what that means. In our last equation, we had something like this. Y equals 3x. All right, the constant of proportionality is basically the unit rate. So let's say it was $3 per baseball. That's that constant. You can see it in this equation right here. It's kind of basically whatever you're timesing the x by. Okay, so that's called the constant of proportionality, and it's always the unit rate. Now, sometimes I also want to let you know, you're going to see it like this. If you take whatever your y is and divide by the x, that's going to give you your unit rate. So you might see it written like this. So again, you know, if I said it costs $9 for 3 baseballs, and I divided that out, I would get 3, which is my unit rate. So that's what the constant of proportionality is. Another way to just think about it is the unit rate. All right, let's say that we have this table, and we want to know, well, is this proportional or not? So you guys can see that the table shows the cost of some different notebooks. So, and the notebooks is the X. So 2 notebooks cost $8. 1 notebook costs $4. 4 of them cost $16. 7 of them cost $28. I want to know, well, is this proportional? So one way that you can figure it out is you can take your Y divided by your X. Okay, and it should be the same for every single one of these. That's going to give you your unit rate or your constant of proportionality. So let's go ahead and start with the first one. I have 8, and if I divide that by 2, that gives me 4. Okay, let's go to this one, the second one, 4 and 1. If I do 4 divided by 1, that gives me 4. If I do 16 divided by 4, here's my 4, that also gives me 4. And if I do 28 divided by 7, that also gives me 4. Okay, so that basically tells me my unit rate for my notebooks is it costs $4 per notebook. Okay, and you probably could have figured that out just by looking at the table. If 2 of them cost 8, to get here, it's times 4, right? 1 times 4 times 4. Okay, it's $4 per notebook. So this is proportional. Okay, our next example is we have William. He made some cookies over a constant hour. So we're going to try to go ahead and graph this situation. All right, so it looks like he was cooking for 1 hour. He made 15 cookies. So I'll just go ahead and plot that. 1 hour, 15 cookies. 2 hours, he made 30. 3, he made 45. 4, he made 60. 5, he made 75. Now, they did not put this in the table, but what about 0 hours? If he was cooking for 0 hours, he would make 0 cookies. So I can graph that. Okay, it looks like it's going to make a straight line. All right, and I want to know, well, is this proportional? Well, first thing I notice, well, it's linear. So that kind of makes it proportional. Second thing I notice, it goes through 0, 0. So that makes it proportional. Third thing is there a unit rate? Is it consistently going up by the same amount? Well, in 1 hour, he makes 15 cookies. Is that true? Is 2 hours 30? Does that make that true? Well, if I double it, yeah, that's equal. Same thing here. If I triple this and triple this, that works. It's changing by the same rate. The unit rate is 15 cookies in 1 hour. So it has a constant rate, so this is proportional. All right, this time I have a situation where I'm looking at how many glasses of water Tom drank over a certain number of hours. So I'm just going to kind of look at the graph, and I'm going to make a little table. So here's how many hours he's drinking, and here's how many glasses he drank. So it looks like in 0 hours, he drank 0 glasses. And then I see in 5 hours, you can see that he drank 10 glasses. In 10 hours, he drank 20 glasses. You guys seeing how I find this? 15 hours, he drank 30 glasses. 20, he drank 40 glasses. And in 25, he drank 50 glasses. All right, so I want to know what's the constant of proportionality. Basically, that means what's the unit rate? Okay, again, that's just another word for it. So how many glasses does he drink per hour? Well, I can see he drinks, in 5 hours, he drinks 10 glasses, right? 10 hours, he drinks 20 glasses. Well, I want to know how many glasses does he drink in just 1 hour. Okay, so let's kind of think about this. So he drinks 10 glasses in 5 hours. I want to know how many does he drink in just 1 hour. Well, let's go ahead. Let's see. If I do 5 to get to 1, it's divided by 5. So 10 divided by 5, that gives me 2. So he drinks 2 glasses per hour. Okay, another way to find that is you could do the 10 divided by 5 here, you get 2. 20 divided by 10 here, you get 2. 30 divided by 15, again, you get 2. 40 divided by 20, you get 2 every single time. So my unit rate, or my constant of proportionality, is he drinks 2 glasses every hour.